We want to dance, dance, la 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 la, ooh. And I'll spin and dance and I'll even break it down. Wiki, wiki, wiki. Oh. Look at this new set. We finally made it big time. Ah, yes, I love it, don't you?
Math homework helpers, it's time. Math homework helpers, oh yeah. Math homework helpers, it's time. Math homework helpers, oh yeah. Multiply, divide, add or subtract. Figure what the answer will be. You can do it with a little help from your friends here on TV. Math homework helpers, it's time. Math homework helpers, oh yeah. Math homework helpers, it's time. Math homework helpers, oh yeah.
It is better to offer no excuse than a bad one. Observe good faith and justice towards all nations. Cultivate peace and harmony with all.
Cal, what's with the quotes?
Yeah, well, it's George Washington's birthday today, of course. These are my favorite GW quotes.
Cal, I like this one. It is far better to be alone than to be in bad company.
Ah, so true, Miss Magazine. Oh, that's a good one. I like that one.
What about puppets are the play of idle hand and mind?
What? Washington didn't say that about puppets.
Well, what about this one? The only good puppet is a silent one.
What? Hey, Washington didn't say either of those two. You guys are messing with me and on Washington's birthday to boot.
He did say math is the great equalizer. Know it well.
Ah, yes, Miss Frist, he did. That was a good one. So what do you say we get right to that equalization and start the show? Welcome, kids, to Math Homework Helpers. This is Miss Frist from Pine Grove Elementary School, and this is Miss Magidson from Windsorville Middle School. And I am me. Calculate.
The prize wheel is ready to go, and our special guest spinners today are Dami from Scotts Branch and Alyssa from Mars Estates Elementary School.
Hey guys, thanks for
Welcome.
joining us today. Oh good, we'll be spinning that wheel and having a good time for sure.
We're here to help BCPS students with their math homework helper. So if you need some help with your math homework, go ahead and give us a call. The number is 410-494-1459. That's 410-494-1459.
Hey, Miss Frist,
59.
what's
Yes.
the number again?
410-494-1459.
You know what I like to tell the kids to do? Get a big black magic marker and write it on the wall. Good idea?
Good idea.
And after we work on your math homework, you get to spin the prize wheel, huh? All right, now, let's go to our very first caller on this spectacularly sunny, like 70-degree Wednesday afternoon. Can you believe it's winter?
I can't.
Hey, who do I have on the phone today?
Eric Sullivan,
Hey, what's going on? What school do you go to?
Deer Park Middle Magnet.
Oh, fantastic. I love that school. So, Eric, you guys are doing a little multiplication today?
Yep.
And did you know that today was George Washington's birthday?
Yes.
Oh, you see? They're smart over there at Deer Park. Well, what multiplication are you working on? And we'll work on it together. Our founding fathers would be proud of us.
Okay, I'm working on 16,341 times. You got it?
Yes?
Times 48,000. Yes, 48,000. I think 881.
Wow, that's a lot of multiplication.
48,880?
Yes.
All right. So you have a lot going on in this problem, Eric. We're going to get you started, and then hopefully you'll be able to take it from there. Is that okay?
Uh-huh.
All right, so the first thing we're going to do is multiply by our very first placeholder, which is 0. And what's 0 times anything, Eric?
0.
Absolutely.
Wait a minute, you mean 0 times 10 million is still 0?
It's still 0, Cal.
All right, just checking.
So now I'm going to move over to the next one. And what is 8 times 1?
8.
All right, I'm going to test you on your facts here. What's 8 times 4?
32.
All right, and what do I do with the 3?
You put it on top of the.
Exactly, I'm going to carry it over to the next one. Let's keep rolling. What's 8 times 3?
8 times 4. Oh, 24.
And what do I do with the 3?
The 3.
Yes, the 3 that I have that I carried over.
You added after.
I have to add it. So it's 24 plus 3.
27.
All right, I'm going to put that 7 down here. I'm going to carry that 2 again. And what's 8 times 2?
16.
And then I need to do what with that other 2 that I have up there?
Add it, which would be 18.
Absolutely. And I'm going to carry the 1. And what is 8 times 6?
Times 6 is equals to 48.
48. And I still have a 1. What do I do with that?
Add it to make 49.
All right. So that's our very first set of multiplication. Now, I have another 8, and I have to annex my zeros. Do you know what that means?
Yes, that means annex. This wonderful Miss Seth taught me that.
Miss Seth taught you that. Okay. So I'm going to put a 0 here. And how about another 0 here? Does that work for you?
Yes.
Why do you have to put another 0? Is that...
Because here I am at the 8 cal, and I have 2 placeholders behind it.
Okay.
Okay? So now, well, guess what? If I'm doing 8 times this whole number all over again, what do you think I should just be able to do, Eric?
I write the same numbers.
I'm going to write the same numbers, starting from the 8, then the 2.
What if you make a
7.
mistake in the first set of numbers?
Ah, well, you're absolutely right. We should go back and double check, but I think we got it pretty good here since Eric and I have been working together. Now, you're going to go ahead and do the same thing. Eric, how many zeros would I put in this row?
3.
Absolutely. 1, 2, 3. And then I'm going to do the same numbers all over?
Just do 8, 2, 7.
Absolutely. And now, when I do the 4, how many zeros would I do in that row?
4.
Absolutely. Do you think you could take it from there, Eric?
Yes.
Once you do all of the multiplication, what do you do with this row, this row, this row, and this row?
Add everything.
Add them all up.
Add them up. Hey, one more thing, Eric. What do you call the answer in a multiplication problem?
Hold up, I cannot hear you.
What do you call the answer in a multiplication problem?
My teacher just told us that.
It's got that special name.
Miss Chess taught me that too. Oh God.
It begins with a P.
Prod.
Papada.
Yeah! There you go! All right. Well, Eric's going to take it the rest of the way, right? So, I would suggest that we spin the wheel for Eric, and Dommy's going to do the spinning for you, all right?
All right.
All right, Dommy. Give it a good twirl. Yeah.
Ooh, nice thing.
What do we have? Hey, a flashlight. I just happen to have one right here.
Oh, this looks cool.
Pictures for me. I can't turn it on. I don't have opposable thumbs, you know?
Okay, I got you, Cal.
That'll shed some light on the subject.
Very funny, very funny.
Your
All
teeth
right.
marks are in it.
Yeah, it's a little slobbery, too. Sorry about that. All right, hey, you know what? Let's move on to our next caller. Hey, we're going to Norwood. Chahad, are you there?
Yeah.
Hey, how are you?
Good.
How's everybody at Norwood today?
Good.
Did you know that it was George Washington's birthday today?
Yeah.
Well, look at that. Everybody seems to know. Fantastic. So you're working on the little division over there, right?
Mm-hmm.
What's your division problem? And I think what? Miss Frisch, you going to write this one
I'm
down?
gonna help him out.
All right, let's do it. What do you got?
24 divided by 6.
Okay.
24 divided by 6. How do you know how to put which number where?
Oh, good idea.
Ah.
Are you using a
Good
division
question.
house?
Oh, a
Are
division
you
house.
using a
Oh,
division
cute.
house? What number goes inside your division house? Is it a 24? Like this?
I can't see it.
Okay, so you have 24 and you're dividing it by what number?
6.
Okay. So you have 6 groups. How many, what times 6 would make 24?
4.
4. Okay, is 4 times 6 exactly 24?
Yes.
Okay, so I think you just solved your problem because there's no remainder left over.
So if you know your multiplication facts, you know that that answer pretty quickly, huh?
Mm-hmm.
You did great finding the quotient. The quotient was 4. Good job.
The quotient. I don't know. Why do they call it a quotient? Or why do they call it a product? And why don't they just call it the answer?
I'm not sure.
Mathematical wizards, huh? Well, I'll tell you what. I think we should spin the wheel. Alyssa will do the honors. There she goes. There she is. All right, Alyssa. Give it a good spin. All right, here we go, here we go, here we go. Oh, a water bottle. How apropos for a hot day like this in the middle of February. This global warming thing is...
I think you're right.
It's not so bad so far. Okay, I'll tell you what. Why don't we go to Newtown? Tanya, are you there?
Yes.
Hey, how are you today?
Good.
So you're working on mode, correct?
That.
Is it mean, median, mode, or just the mode?
Mean, medium, mode, and range.
I'm in the mode to learn this. I crack myself up.
What's your question?
Usually I'm the only one laughing at my jokes.
Hello?
Yes, Tanya. Even Titania's bored. Let's go. What's your problem, Titania? We'll work on it together.
It says find the mean, median, mode, and range for each set of numbers.
Okay.
Miss Frisk, can you write those numbers for me, please?
Sure. Why don't you give us your set of numbers?
Yeah.
Tanya? 5.
6.
6.
5.
5.
2.
2.
4.
4.
5.
5.
1.
1.
That it?
Is that your set?
Mm-hmm.
Okay, great.
So what's the first thing that we need to do before we start dealing with any one of those measures of central tendency?
I like the vocabulary, Miss Magginson.
What do we have to do?
I have to
Get a snack?
no.
I'll give her a hint, though. How about let's put them in order from least to greatest? Do you remember?
Okay.
I'd rather have a snack.
So if we're going to put them in order from least to greatest, which number am I going to write first?
1.
Okay. And then what number is going to come after the 1?
2.
It's a little hard with me writing across. What comes after the 2?
4.
Okay. And the next number?
5.
All right. Keep going.
Then another 5.
Absolutely. Keep going.
Then another 5.
Mm-hmm.
Then 6.
All right. So our numbers are in order from least to greatest. Now, you asked to find the mean, median, mode, and range, correct?
Mm-hmm.
Well, let's start with the range first. What is the range?
Range is the difference between the greatest number and the least number in a set of data.
All right. So what's the highest number?
6.
And what's the lowest number?
1.
What's 6 minus 1?
6 minus 1 is 5.
All right. So what's your range?
5.
There we go. Now, we need to find the median. Are you okay with doing the medians next?
Yes.
And what is the median?
Median is the number in the middle of a set of data that is ordered if there is an even number of data calculated the average of the two middle numbers.
All right, I like it. Sounds like you have a great definition in front of you. So let's see. If I go in 1 and 6.
I can help.
Okay.
Want to cross off each
Sure,
pair together?
please. Yes. 1 and 6. Oh, we're only going to be able to do 1 at.
Oh, gotcha.
All right. And then 2 and 5. And then 4 and 5. We only have one number in the middle, so we don't even need to do an average here. What's my median going to be?
5.
All right.
Well, the range is 5 and the median's 5.
Yeah, how about that? That's not always going to happen, though.
Oh, that's true.
All right. Now let's do the mean. Well, let's do the mode. The mode is the easier one of them. Do you know what the mode is?
Mm-hmm.
What's the mode?
Mode is the number of mode is the number of numbers that occur most often in a set of data. There can be more than one mode or two mode.
Okay, so we can have Great definition. We can have more than one mode. But right now, what number do you see the most amount of times?
5.
Wow, how about that? So far our range is 5, our median is 5, and our mode is 5. What are the chances that our mean would be 5? Do you know another word for mean?
No.
Okay, another word for mean is average. So basically, we're going to find the average of all these numbers. And do you know how we find the mean or the average?
No.
All right, so we're going to add them up. So I'm going to rewrite this 1, 2, 4, 5, 5, 5, and 6. And what I'm going to do is I'm going to put plus signs in the middle of all the numbers. Okay?
Mm-hmm.
And how many numbers did I add? Let's count them. 1, 2, 3, 4, 5, 6, 7. So once I finish adding all those up, I'm going to divide by 7 because that's how many numbers I have.
Okay.
All right? So let's start adding. What's 1 plus 2?
3.
3. What's 3 plus 4?
7.
7. Well, look at that. 5 and 5. What's 5 plus 5?
10.
10. And 10 plus the 7?
17.
17. And what's 5 plus 6? You know 5 plus 6?
11.
11. So I'm going to do 11 plus 17 just because it's easier to add them up that way. And what's 1 plus 7?
1 plus 7 is 8.
And 1 plus 1?
2.
All right. So are we okay with that so far?
Yeah.
All right. Did we do that right? Are we good? Okay. So now we have 28 divided by 7. Because we got 28 on the top, 7 on the bottom. And do you know what 28 divided by 7 is?
Thinking about those multiplication facts.
What's 7 plus 7?
3.
3, okay. 7 plus 7 plus 7 is 21. We need one more 7. So how many times does 7 go into 28?
8 times.
Let's see. 7 plus 7 plus 7 plus 7. You said 3 at first. 7 plus 7 is 14. Another 7 is 21. Another 7 would give us 28. How many 7s did we have? 1, 2, 3, 4.
Yeah.
So 28 divided by 7 equals 4. Our range, our median, and our mode were 5, but our mean or average is 4. Did that help you out?
Yeah.
And guess what you get to do now?
Oh, yeah. Yeehaw! Tommy's going to do a little spinning for us. Get ready. Get ready, cowpokes. All right. What he gets? Oh, look at that, an MP3 player. What do you know?
Nice.
All right. Hey, you know what? We're going to send that out to your school, and you can put your favorite tunes, like Math Homework Helpers theme song. Huh? That's cool. We should send them out with that on there.
Sounds
We
good.
should.
Let me see. Note to self. All right. That'll be lost very quickly. Okay, let's move on to Pine Grove Elementary School. Daniel, are you there?
Yeah.
What's going on?
Nothing.
Did you know that it was Washington's birthday today?
Yeah.
Seems like everybody knows, huh?
But Cal, you did tell him at the beginning of the show.
I did, didn't I?
Yeah, you did.
That fact eluded me.
I think so.
Okay, well, let's do some work there. What do you got for us, Daniel?
I have an input-output table.
Hi, Daniel. Tell me about your input-output table.
You know Daniel?
I know Daniel.
So
How?
in the input, there is 0,
She knew Daniel.
0,
7,
7,
14,
14,
21.
and 21. Okay. Daniel is one of my fabulous students at Pine Grove.
Oh yeah, that's right.
That's right.
You work at
And
Pine
then
Grove.
output,
Another fact that eluded me for the moment.
0,
Uh-huh.
1,
Uh-huh.
2.
Okay.
And then I have to find out what comes after 21.
Okay. So Daniel, how are we going to figure out what comes next in our input-output table? Can you tell me about the rule that we need to find?
Well, it doesn't show a rule, so I just trying to figure it out. Like.
Okay.
Hey, Daniel, could you turn your television all the way down and just talk to us over the phone?
Yes, sir.
We can hear you a little better if you do that.
Ah, thank you, Daniel.
Okay, so the options to go after 21 is 3, 4, 8, and 10.
Okay.
And I don't know if I should do addition, subtraction, division, multiplication. Probably
Okay.
not multiplication or addition.
All right, Daniel. So your input here, when you go to your output, the value is staying the same. So let's look at the next one. Your input is a 7 and your output is decreasing, right? So if the value is decreasing in an input-output table with whole numbers, then what are the two operations that you could only use for decreasing?
Subtraction and division.
That's right. So you could subtract to get 1 or you could divide. Okay, look at the next value. What rule comes to mind when you keep going from 7 to 1 and then from 14 to 2?
Division.
Division. And what fact would you be dividing by? 7 divided by what is 1?
7 divided by 7 is
Yeah. Let's see if it keeps working. 14 divided by 7, is that 2?
Yeah.
Okay. So then what's 21 divided by 7?
3.
It's 3. Absolutely. So what do you think your rule was there for that input-output table?
Divided by 7.
Yeah, definitely. To divide by 7. Awesome. Way to go, Daniel. Thanks for calling in, buddy.
I haven't seen one of those input-output tables for a while.
Yeah, he did a great job.
They're fun. I like those. It's the old noggin working.
Definitely.
Alrighty, you know what? Let us spin the wheel. Are you ready? Alyssa, please do us the honors. And the wheel's spinning. And another water bottle. Yes. These are magical water bottles. You guys know that, right? They turn blue when you fill them up with cold water.
I see
And then
a lot
they
of
stay
them.
blue
Yes.
until you put them in the dishwasher.
Awesome.
And then they turn white again. It's fascinating. Anywho, what was I saying?
I think you were getting ready to talk.
Oh, yes, the next caller. Another Deer Park middle schooler. Hey, Sharon, are you there?
Yeah.
What's going on? Whoa, look at my face. I look huge. Whoa. Anyway, what are you guys working on? A BCR?
Mm-hmm.
A BCR. What does that stand for?
Brief constructed response.
A brief constructive response.
That means we're going to get a
That's
nice...
the way I live my life, in brief constructive responses. All right, let's do a brief constructive response right now with Sharon.
It says, Deja's plan for Hawaii landed at 4 p.m. Her flight lasted 2 hours and 15 minutes. On the number line above, use point A to represent the time Deja's plane departed from Hawaii.
Aloha.
Okay, so 4 p.m. was the time that her plane took off?
No. It says Deja's plane for Hawaii landed.
Oh, okay, landed at 4 p.m.
Landed at 4.
So, and the flight was 2 hours and 16 minutes?
2 hours and 15 minutes.
15 minutes. Okay, so that means that we're going to have to work backwards from 4 p.m. So, if you, yes?
On the there's, can I explain to you how the number line is?
Yes, you can.
So it's like a number line, and then there's one line in the middle, and one line at the end, and then another line at the end. And at the first line, it's 1 p.m., and at the end of the line, it's 2 p.m.
Okay. Did you get that?
Mm-hmm.
Sure.
So does it kind of look like this? 1 p.m. here, another line in the middle, and then 2 p.m. here? Is it like that?
Yeah.
Okay, and there's a line right in the middle?
Yeah.
Okay. Do you know what that time is right in the middle?
No.
Okay, well, what's right between 1 p.m. and 2 p.m.?
1:30.
Yeah, so I think you need to get the answer with Miss Magginson and then put it on this number line. Does that sound right? Okay.
Okay.
Yeah.
So if the plane landed at 4 p.m., that means that she got on the plane before 4 p.m., correct?
Mm-hmm.
All right, so let's work backwards. 4 p.m. take away 1 hour is what time?
3 p.m.
And 3 p.m. take away 1 more hour is what time?
What did you say?
3 p.m. take away another hour would be what time?
2 p.m.
2 p.m. Now, we have to deal with the minutes. Do you know how many minutes make up an hour?
60.
60. So what's 60 minus 15?
45.
All right, 45. So that means if we had 2 o'clock minus 15 minutes, that's 45 minutes. What hour are we working with? We went from 2 and just took away 15 minutes. Here we are at 2, and we went back 15 minutes. What's from 1:30 to 2? Do you know how many minutes are in between this space right here?
30 minutes.
30 minutes. And what's half of 30? If I cut this in half, what's half of 30?
15.
45. So 1:45, here's where we are. This would be your actual time that she had to take off on the plane. We counted back from 4 to 3 to 2 and then 15 minutes, and that gave us the 1:45.
Is it okay if I do part B on there? Because I don't really get that either.
Okay, what's part B?
Part B is create a new number line that represents 15-minute intervals to represent the time Deja's plan departed from Hawaii.
Oh, well, we actually just did that for you. So if this was your original number line, you had 1 p.m., 1:30, and 2 p.m. Now, between this 1 and 1:30, that's a half an hour. If you cut a half an hour in half, a half an hour makes up 2 equal 15-minute parts, correct?
Yeah.
So 1 p.m., 1:15, 1:30. Another 15 minutes added to 1:30 is 1:45. Another 15 minutes added to 1:45 is 2 p.m. That would be your new number line.
So
you like split it up into
Yes.
quarters.
Yep, just like fractions.
Like it. I wish I was in Hawaii right this minute.
So do I.
And where do you fly from that you could actually leave Hawaii? Where would you land in 2.5 hours from Hawaii? Like another Hawaiian island or something?
Maybe.
Wouldn't be Maryland.
No.
Okay, hey, let's spin the wheel. Enough of this travel talk. All right, Tommy, you ready to spin? He's got the good luck sombrero spinner. Sombrero of luck. Brings a fleshed rod.
I got it this time.
Yes.
Don't slobber on me. Thank you, thank you.
Sorry about that.
No problem, no problem.
We tend to slobber a lot, us wolves, you know. Mm-hmm. Comes with the DNA.
Here, why don't you put this
Much
back?
better.
Put that back. There you go.
Okay, enough of this slobberness. Let's go on to our next caller. Ziad, are you there?
Yes, I am.
All right, how is Newtown today?
It is good. It's still good.
Fantastic. How's Miss Chess today, huh?
Miss Chess is wonderful.
Oh, that is nice to hear.
That's
She's wonderful
great to
wherever
hear.
she goes. Okay, so you're working on a word problem?
Yes.
All right, which one are you working on? And we will listen very carefully.
The question is, what is the value of the following expression? N minus 178 if n equals 227. A, 49, B, 59, C, 395, or D, 405.
Okay, I didn't write down all your choices, okay, but I think I have your expression correct. N minus 178 if n is 227, is that correct?
Yes.
Okay, so what do you think we should do here to solve this expression?
Well, since it's subtraction, it should not be, the answer should not be greater than 227.
Okay, you're right, because that's right, you're taking 227 and then you're going to take some away from that. So it is going to be less. That's great thinking.
Yeah.
Okay, so what should we do?
We should take 227
Okay.
and subtract that by 178.
Okay, that sounds like a plan. This right here, since you know that that's n, you can substitute that. Have you heard that word before?
Yes.
And do that subtraction. So let's write it up and down so that we're sure that we subtract correctly. Okay?
Yes.
All right, can you take 8 from 7?
Hold on a second, let me write it out. Okay.
Okay.
You can't do 7 minus 8, so you have to take cross out the 2, put a 1, make the 7 a 17.
Awesome.
And 17 minus 8 is 9.
Great. And now we're 1 minus 7. Can we do that?
No, you cannot. Take a 1 from the 2, make that a 1, and make the 1 11.
Very good.
And 11 minus 7 is 4.
Okay. So what's your final answer? What's the difference between those two?
It is 49.
Right. And you told us from the beginning it needs to be less than your original number. Did that work out for you?
Yes.
Yeah, you did a great job. Is that one of your choices?
Yes, it is.
Very good.
So that's an expression, huh?
That's an expression.
A mathematical expression.
Mathematical expression, yep.
I like using mathematical vocabulary.
Me too.
Well, what if we added an equal sign to it? What does that change it to? It goes from an expression to an equation.
Oh! Oh, this stuff is awesome. Let's spin the wheel while I ponder that for a while. Okay, are you ready, Alyssa? Let us spin the wheel. All right. Oh yeah, the backpack. I got one right here. Here is one of our lovely maybe one of you two gals could open that
Got
up.
it?
Yes.
Oh, nice color.
Yes, it
Turn
is.
the right way.
I
There we
particularly
go.
chose the color because it matches my eyes.
Oh, nice.
See?
Let's see that.
Very nice.
Yes, it does.
See my eyes?
Beautiful.
We'll get a close-up of my eyes. They're beautiful. Maybe on the next shot we'll get a close-up of me eyes. Okay. The eyes have it. Let's move on. Hey, Titania, is that you again?
Yeah.
Wow, you must love us.
Yep.
Hey, did you know that it was George Washington's birthday?
Nope.
Ah, you see? Now you do. What's your favorite George Washington quote?
I really don't have one.
How about, I'll never tell a lie?
Okay.
That's a good one. That's an important one.
You should remember that one.
Yes, you should. No, you shouldn't. I'm telling a lie. All right, what do you got for me? What are we working on now, Titania?
Slides, flips, and turns.
Wow.
Oh, sounds like a dance. Slides, flips, and turns.
It actually does,
Like
but
a
it's
line
geometry.
Dance, the
It says
electric slide.
right,
Dating
flip,
myself,
slides,
aren't
or turns, or to tell how the figures was moved.
Okay. This one we might need to see. You're gonna have to be very, very specific because I'm sure you have some pictures on here, correct?
Mm-hmm.
Okay, so you've got to do a really, really good job in describing your picture for us.
Okay, I have
Yeah,
two L's facing the same side.
2 L's.
Like,
We'll do what we
It's
can,
the
and then
right
we'll have to come up with another
side.
example.
All right, is it on a grid like this? Do you have it like that?
like, it's just a regular old L. And then
Okay.
it's another one like that one, and it's facing the right side.
Okay, so are they L's that look like this? Are they on a grid or not?
Yes, they're like that. But the other one, the one on the right side, is facing the other one, but different directions.
Does it look like that?
Yes.
Okay, and what's your question? What do you want to do to the L's?
It just says like is it a flip, slide, or turn?
Ah, okay. So basically what they're saying is, I'm going to erase one of these, okay?
Okay.
So a slide is if I just move left to right, okay? If I just go like this.
It's electric.
And a flip is if I actually winded up flipping over this way, so I might look like that. And then a turn is if I'm looking like this and I actually kind of like turn it a certain degree. So if I have it like this, now maybe it looks like that. Okay? So those are all the different choices that you could have. Now, taking a look at what you had, did we flip it? Your L. Your first L, if this is your first L, and it still looks the same on that side. So we didn't flip it, correct?
Yeah.
We didn't turn it either because it's still looking the same way, facing all the same directions.
Yeah.
All right? So what can you say happened? Did we slide it from one side to the other?
It's electric.
Yes.
I'm telling you.
This is a slide. This L slid over to that side. Okay? Does that help you?
Yeah.
All right, good job.
Flip. Slide. We got to make a dance out of this.
Okay.
I'll work on it after the show. You guys
You
wanna
do
help
all
me?
the flips.
I'll do the flips.
I'll slide.
I flip for you guys
turn.
anytime. Alrighty, hey, you know what? Why don't we go out to Glendon and talk to Trey? Oh, no, sorry, I gotta spin the wheel. I was thinking about my dance. Let's slide over to the wheel. Come on, Dommy. Let's spin the wheel. Yeah. Oh, look at that, some sunglasses. On a nice sunny day like this, you could really use a pair of sunglasses and a math homework helper's water bottle. Both.
Absolutely.
We'll
Let's see if we can win another one of those.
Yeah, we should. I don't know where. Well. All right, hey, you know what? Now can we go to Glendon? We'll
Yes,
talk to
let's
Trey.
talk
Are you
to
there?
Trey.
Yeah.
How you doing, Trey?
Good.
Great. So you're doing a little multiplication over there?
Yes.
Now let me ask you a question. Did you know today was Washington's birthday?
No.
See? Not everybody knows. Well, it is. Happy birthday. Happy birthday to you, too. Is it your birthday?
No.
No, I was just taking a guess. So let's get your multiplication problem and we'll figure it out together.
All right. It is 37 times 9.
Okay. So your first factor
37?
is 87.
Oh, 87.
87. And you're multiplying that by your second
No,
factor.
37.
37.
Oh, it is 37.
Oh, it is 37!
You have good ears. Very good ears.
You'd never know.
No.
More
37
misinformation from
times 9, is that your second factor?
Yeah.
Okay. So what is the answer to the multiplication problem that we're going to find here?
the product.
Thanks.
I
Was-
think
Is that what you were asking?
Uh-huh.
Sorry, I shouldn't have jumped the gun.
It's a product. Okay, let's find your product. What should we do first, Trey?
times seven times 3.
Not 7 times 3. You're
No,
doing
9 times 3.
that 9 times what?
7.
Yeah, 9 times 7. You're doing 37 9 times. So you have to multiply the 9 times the 7 and then the 9 times the 3, right? So what's 9 times 7?
63.
Good job. The 3 goes below and the 6 up top.
Uh-huh.
Okay. So now you're going to multiply the 9 times the 3. What's 9 times 3?
30. Wait, no. 9 times 3 is 27.
Good. And then you have 27 and you have to add that 6 on. So what's 27 plus 6?
33.
Good job, 33. So we're going to put that down here. So your product is 333. Way to go, Trey.
Thank you.
333. That's the product,
That's
eh?
the product. And he wants to spin the wheel and win a water bottle.
That what he said?
Or something else great.
Okay,
He
we
did.
can do that.
Yeah.
I can't guarantee the water bottle, but I can guarantee you something. Alyssa will be spinning the wheel. There she goes. And here comes the spin. Oh, look, what are the chances of that? Miss Frist, you better start playing the lottery.
I think so.
Well, a magical water bottle will be coming your way, and this one will be specially magic because it was predicted right here by the amazing Kreskin. Okay, let us move on to our next caller. Another Newtown caller with some sort of an expression. I have an expression of confusion. Is it Brianna?
Yes.
What kind of expression? Is it like this kind of expression?
No,
crazy
not
expression.
really.
Or how about my happy expression?
No.
Or my sad expression?
No.
What expression is it?
It's a math expression.
Oh, well, I guess I should have figured that.
Yeah.
What is it?
Okay. Valerie mailed a package this week that was 10 pounds less than the one she mailed last week. Use the letter W for the weight of last week's package. What is the expression for the weight of the package Valerie mailed this week?
Okay, so we know that she mailed a package last week, but we don't know how much it weighed, correct?
Mm-hmm.
And what do we call a letter that represents something that we don't know?
A variable?
A variable. Nice job. So they already told us to use W as our variable.
Wow.
And the package that she's going to mail this week is 10 pounds less than the first one, correct?
Yes.
And what operation is less than?
Subtraction.
So there you have the weight of the first package minus the weight of the second, which would be 10, and that will be your expression.
Okay.
Do you have any more to your problem? Was that it?
No.
That's a heavy package.
All right, nice job.
What do you think she was mailing? If it's over 10 pounds, that's a lot of something.
Yeah.
Really awesome. Be a bowling ball?
Could be.
A side of antelope? Alrighty.
It could be a book. It could be a math book.
It could be a big, heavy book. Or maybe a math book. Alrighty. You know what time it is, don't you?
Yeah.
What time is it? What, 4:40? 4:50? Time to spin the wheel! Woo! Alright. Spot on the wheel. Come on, come on, Miss Frisk, what's it gonna be? You were gonna say sunglasses, weren't you?
I was.
I knew it! I must get some lottery numbers before you leave.
Okay.
Okay. Kaylee, are you there? From Arbutus Middle School? Look at my eyes. Aren't they beautiful?
Beautiful.
Blue. Like a
Hello.
blue.
Hi, Kaylee.
Kaylee, how are you?
Hello.
How's everybody over in Arbutus today?
They are fine.
Outstanding. Hey, did you know that it was Washington's birthday?
Yes, I did.
Happy birthday, Georgie! And is it your birthday?
No.
Eventually, one of these kids is probably going to be their birthday. You know that? Just the way mathematical statistics work. Oh, anyway, so you're working on geometry, right?
Yes, I'm working on area.
Oh, area. Love area. So useful.
Yeah.
All right, what's your area of expertise?
I am working on it's
And then?
a rectangle with a triangle, and one side is 8 millimeters, the other side is 12 millimeters, and the other side and the bottom is 5 millimeters.
Okay, so I'm going to have to draw you a picture here. You have a rectangle. Okay, one side was 12 millimeters. And what was the other side?
It's 8 millimeters.
Okay, and then you have attached to it a triangle?
Yes.
Okay, is it coming off the side like this?
The other side is the opposite of the 12. That's 5 millimeters.
Opposite of the 12. So right here is 5 millimeters?
Yeah.
Okay.
Is the triangle,
is the triangle
on, that side?
on the side right here? Next to the 5 millimeters?
The 5 millimeters is on the other side where the 8 is.
Okay.
Okay.
And the 8 is where the 5 millimeters is.
Okay, the 8's where the 5.
Switch those.
Hold on 1 second. So this is a 5. Okay. And where's the 8?
Where the 5 was.
Okay. And where's the triangle you were talking about?
It's on the across from the 5 on the triangle is, it's on the other side of the 5.
Okay, is it coming out like this?
It's going straight from the 12 millimeter.
Mm-hmm.
And then from the 8, it's diagonal.
Okay, if I draw it like this, is that correct? Can you see it?
Yeah.
Okay, so why don't we work on your rectangle first?
All
okay,
right.
and then we'll look at your triangle. What is the formula when you're finding area of a rectangle?
We would do 12 times 8.
That's right. And we're going to do the length, which is 12, and we're going to times that by, what's the other dimension? Length and?
Times width.
Width, that's right. So let's look very carefully at your rectangle, okay? The length is 12, you had that right. Mm-hmm. But what is your width?
8.
I think this 8 must be attached somewhere to this. So I think your width is right here. I think it's a 5.
Okay.
Okay, because it's your opposite side, and these two are adjacent. Do you see that? So
yeah.
This right here, your width, this is your length. So let's go ahead and do that.
Okay.
What is 12 times 5?
16.
Good. So it looks like your area is 60 millimeters squared. Okay, so we'll put that in there. All right, now let's talk about your triangle. Do you have any dimensions for your triangle for me?
No, because we are trying to find the what's the area of the triangle.
Okay, well, if you look at this, if you look right here at this 5, and you go opposite to the other side,
so
this is also what dimension?
So it'd be 5.
That would be 5. Did they give you a height at all for your triangle? Yes
they
or
didn't.
They didn't, okay. I think we're going to need the height to find the measurement of the area for the triangle.
Where is the 8? Is the 8 in our picture at the right spot?
What did you say?
The 8 that we have in our picture, is that correct, or is the 8 over by the triangle?
It's correct.
It's correct. Okay, so, well, we have your rectangle. Let's do this. Tell me how to find the area of a triangle.
In my math class, so what we did base times height divided by 2.
Okay.
So you set it up like this, base times height divided by 2. Okay?
Yeah.
So since my drawing might be a little different than yours, once you have your base here, which is a 5, once you figure out what your height is, if you multiply that and divide, then you'll be able to figure out the area of the triangle. Okay? So you might have to look at this part a little bit more closely to find that height. Okay? Once you get that area of the triangle and you already have the area of the rectangle, what are you going to do with both of those areas?
Multiply?
Well, if you're finding a total, because this is a composite figure where you have two different shapes, if you're finding a total, you don't want to multiply to get it. You want to take the 60 millimeters squared and add it to whatever else you get. Okay, and that's going to give you the total area.
All right.
Okay, does that sound good?
Yeah.
All right. So, sorry I couldn't help you a little bit more with that drawing, but
It's okay.
try to find that height, okay?
An area is a valuable thing to know how
Absolutely.
to do because you can figure out how big your yard might be or if you need a rug or something, you know?
Tile.
Yeah, definitely.
Or a fence to keep a wolf from running away?
Who wouldn't want a wolf like me running around their backyard, huh?
From running away, we need to keep you fenced in.
You can't fence me in. I am a wild, free beast. All right, let's spin the wheel. What do you say?
I think
Sounds good.
Let's let them spin. Come on, Alyssa. You can't tame me. Others have tried. Whoa, the magic spin. Oh, look at that. MP3 player, another one.
Nice.
Great.
Wow,
prize.
this is a lucky show today. We've got the amazing Kreskin, plus we're giving out the MP3 players. Oh, and you know what? Let's go back up to Deer Park Middle School again. Syria, are you there?
Yes.
Am I saying your name right?
No.
Oh, how do you say it?
Zaria.
Zaria! Wow, I love that name.
Thank you.
So anyway, you're working on some multiplication of some sort?
Yeah, I have to find the value.
Oh, value. Oh, what's your problem? And these fabulous mathematicians here will help you figure it out.
Well,
I'm a
it's
color
a
commentator,
rectangular
figure that out,
prism, and the lengths are
That flair.
the little measurements are 6 feet, 5 feet, and 30 feet.
What was is this a drawing or a word problem?
It's a drawing.
Okay, and what's the item?
A rectangular prism.
Oh, a rectangular prism.
Ooh,
Okay.
rectangular prism.
Well, what do we know about finding the volume? You know the formula?
The formula is length times width times height.
All right, so we have volume equals length times width times
All these
height.
formulas today.
And you gave me 3 numbers. What are your 3 numbers?
30, 5, and 6.
3, 5, and 6?
35 and 6.
35 and 6.
No, 35
Oh,
and
I'm
6.
sorry. 30. Times 5 times 6. How about that now?
Yeah,
All right, let's do this the easy way. What's 5 times 6?
30.
Wow, times another 30. What's 0 times anything?
0.
What's 3 times 0?
0.
And what's 3 times 3?
9.
All right, so our volume is 900. Now, what unit of measurement were you dealing with?
Cubed.
Cube? No, well, we know it's going to be cube because we have 3 dimensions. We have a length, a width, and a height. But was it centimeters? Was it in?
Feet.
Feet. Okay, so it's going to be feet cubed. How's that?
Pump up the volume.
Guess what you get to do now, Zaria?
Spin the wheel.
I think
Let's
so.
spin the wheel. Come on. We got Tommy over there.
Ah.
A little bit of move. Yeah. And a T-shirt. A fabulous T-shirt with my face on it. Who could ask for anything else, huh? We'll send that. Zaria, aren't you excited?
Yeah.
Yeah. Maybe I'll personally autograph it first.
That'd be great.
Thanks. All right, hey, you know what? Let us move on. No, wait, Dami, your brother!
Hi.
Hi.
Hey, how do you say your name?
Ayomide.
One more time?
Ayomide.
Wow, I love that name. So you're also from Scotch Branch and you're in kindergarten, huh? Fantastic. What, did you have a math problem you want to work on?
3 circles plus 2 circles.
Say it one more time.
3 circles plus 2 circles.
Oh, 3 circles plus 2 circles.
Okay. 3 circles.
Great job.
What's it like to be a sibling with Dami? Is she nice to you?
Yes, a little. No.
A little.
No!
Would you like to say hi to her? She can hear you.
Oh, yes.
Say hi to your sister.
Hi. Hi, Dami.
Oh.
She's smiling and slightly scared, it looks like. All right, let's add this up.
Okay, so if we add our circles together, let's count them together. Can you count with me? Ready? 1, what's it? 2, 3. What's next? 4 and 5. So you have 5 circles all together. Great job.
Nice. So we just added those up. And now, for the first time ever, we're going to have the siblings spin the prize wheel. That's amazing. It's never happened before. This is a spectacular show. Let's go. Oh, look. I got a flashlight. A slobber-covered flashlight.
Flashlight. What's the pink one?
We will send this right out, and you can use it anytime. Really, it's great. All right, you know what? Let's move to our next caller, and let's talk to Giselle from Dogwood. Giselle, you there?
Yes.
Hey, how are you?
Good.
Great. So you're working on another one of those brief, constructive responses, huh?
Yes, I am.
All right, what is it? And we'll see if we can't get through it.
Okay.
All right, what is it?
Genie is making a number pattern. To get each number in the pattern, he multiplies the previous number by 2.
Okay.
And then subtracts 3. The first number in Genie's pattern is 4. What is the fifth number in his pattern?
All right, so the first number is 4. We need to multiply by 2 and subtract 3. What's 4 times 2?
4 times 2 is 8.
8 minus 3?
8 minus 3 is 5.
Okay, let's keep rolling. What's 5 times 2?
5 times 2 is 10.
And what's 10 minus 3?
7.
All right, let's keep going. What's 7 times 2?
14.
And what's 14 minus 3?
11.
All right, and what's 11 times 2?
22.
All right, nice job. 22 minus 3.
20.
All right, let's try that again. We need to borrow. What's 12 minus 3? Okay, is that going to give us 19?
Yes.
All right, and then 19 times 2, I'm going to help you out very quickly. So we have 2 times 9 is 18, carry that 1, and then that gives us 38. Remember to minus the 3 is 35. And look at that, 1, 2, 3, 4, 5. That will be your answer.
All right, for the last spin of the day, we've got Alyssa. I'm wearing my Lincoln hat. President's Day.
Yeah.
Come on, Alyssa. And there we go. Oh, look at that! A magic math kit. Yes, we will send that right out. I guess we're out of time, aren't we?
I think so.
Well,
that just about does it for this show.
Congratulations to all of our prize wheel winners, and thanks to our guest spinners, Tommy from Scotch Branch and Alyssa from Mars Estates Elementary School. Excellent job, guys.
Remember, kids, we do re-air this episode of Math Homework Helpers throughout the week, so be sure to tell everybody to watch. From all of us here at Math Homework Helpers, we'll see you next week.
Only here on BCPS-TV. I can't see anything with this hat on.
Elvis has left the building.